Today we're going to look at section 6.4, and in section 6.4 we're actually going to start graphing polar equations. So now we're going to take what we learned about plotting points and actually make some graphs like the ones shown. So here's the first example, and it's r equals 4 times the cosine of theta, and we want to graph this equation. Now the first way we're going to graph is by using a table of values, just like we learned to graph when we graphed with x and y's. So we have the equation r equals 4 times the cosine of theta, and we're going to pick some theta. So the first theta we're going to pick is 0. So that means the radius is going to be 4 times the cosine of 0. Now if I look at my unit circle, the cosine of 0 is, in fact, 1. So we're going to have 4 times 1, which is 4. So one point on this graph is going to be 4, 0. That's going to be one of the points we can plot. And we're just going to go down the line and do the same thing. So we're going to do pi over 6 now. We have 4 times the cosine of pi over 6. For the radius, we're really not going to need exact values here. Decimals will work for us. So you can just grab your calculator and you can just type in 4 times the cosine of pi over 6. Now you're going to want to make sure that your calculator is in radian modes in this case because pi over 6 is a radian. Now when you do that, you should get about 3.5. So the next point is 3.5 pi over 6. We're just going to continue doing the same thing. So now we're going to do it for pi over 3. And when we use our calculator, we get the value of 2. So now we're at 2 pi over 3. Now we can continue on the same table. Pi over 2, you'll see is 0. And we can go all the way till pi. Now, you'll notice that after pi, I'm going to start to get repeat answers. So we're going to stop at pi. We're not going to continue the table any more than that. And now that I have all of my points, I'm going to go ahead and plot them on my polar grid. You'll notice this table is on page 658 of your book. So remember, the first thing you do is start at the angle, and then you go out that many radiuses. So 0, and we're going to go out here to 4. The next one, pi over 6, and we're going to go out to 3.5. So we'll be in between some there. The next one at pi over 3, we're going to go out to 2. Pi over 2 is here at 0. 2 pi over 3, we're going to go to -2. So now we're going to have to go down the line 2 backwards. Remember that here's 2 pi over 3, but we have to go back 2 radiuses because it's negative. 5 pi over 6, which is here, we're going to go -3.5. And when we get to pi, which is here, we're going to go -4, and you can see we end up back where we started. You'll notice this gives us, if we connect the points, a circle as a graph. The cosine graph has the same shape as a circle in polar coordinates. Now, in general, the cosine graphs are going to give you these circles. You can see they're centered on that polar axes. And the A value is actually the diameter of the circle. The sine graphs are also going to give us a circle, only their center is going to be on this pi over 2 line. And you can see that its A value is also the diameter. So in general, when you're just graphing plain old sine or cosine with an amplitude, you should end up with a circle graph. There's some ways to make it a little bit easier when we're making our table so we don't have to test so many points. We're going to talk about symmetry for a minute and how to know if there is symmetry in our graphs. Now, the first one is going to be symmetric to the polar axes, which means we're going to flip the point across that polar axis. That would be polar axis symmetry. In order to do that, we're going to take theta and make it a negative theta. If we get back what we started with, we're going to have polar axes symmetry. So we're going to make theta a negative theta and simplify. If we get back what we started with, our graph is going to be symmetric over that polar axis. The next thing we're going to do is replace r and theta with negative r and negative theta. If we get what we started with when we simplify, we're going to say that graph is symmetric to the pi over 2 line. So we can flip it over that pi over 2 line, or the x-axis in terms of x's and y's. The final thing we're going to do is we're going to take r and replace it with negative r and simplify. If we get back what we started with, we're symmetric to the pole. Remember, the pole is like the origin. This is going to help us narrow down the number of points that we have to test in order to graph these. So let's just go ahead and take a look at an example. R equals 1 minus cosine of theta. The first thing we're going to have to do is test all of these. So let's test first to see about the polar axes. Remember, that's where we're going to take our theta and replace it with a negative theta. So we're going to get 1 minus the cosine of negative theta. Now, theta, or cosine if you remember, is an even function. So when you take the cosine of a negative angle, it's the same as the cosine of the positive. Because we got back what we started with, you can see it matches what we started with, we're going to say this graph is symmetric over that polar axis. We're going to do the same thing again, only this time we're going to test that theta equals pi over 2 line, or the, remember that's like the y-axis. And in this case, we're going to replace theta and r with negative r and negative theta. So now we're going to turn both of these into negatives and see what happens. I know once again that cosine is going to turn just to positive theta and nothing's going to change there because it's even. We can ignore that negative sign. I'm going to have to divide everything by a negative 1 to get r back to being positive. And I get negative 1 plus the cosine of theta when I divide by a negative 1. Because it changed from what I started with, this tells me nothing about the symmetry to the pi over 2 line. Now, this doesn't mean that it's not symmetric to the pi over 2 line, but it does mean that it might be, but it might not be. So it doesn't mean that it's not, it means that we don't know for sure that it is. The last one we want to test is if we're symmetric to the pole. So we're going to put a negative r in place of r. So we'll have negative r equals 1 minus cosine of theta. And when I divide by a negative 1, I get negative 1 plus the cosine of theta. And again, this doesn't tell me anything about the symmetry of the pole. It doesn't tell me that we're for sure symmetric to the pole. So all I know is that I'm symmetric over the polar axes. So that means that whatever I get for quadrants 1 and 2, we can flip those over and it'll be the same in quadrants 3 and 4. So now we're going to go ahead and test some points here. Let's go ahead and just test some parts in quadrant 1. So we'll start with 0, pi over 3, pi over 6, pi over 2. Let's switch pi over 3 and pi over 6 around so we're in order. And then we'll keep going and do 2 pi over 3, 5 pi over 6, and pi. Now, remember, we're going to stop there because we know already that whatever I get in the top 2 quadrants, I can flip them over and plot those same points in the bottom because of that symmetry we just found. So to find r, we'll have to do 1 minus cosine of theta. Now, I'm going to use, and I'm sorry, cosine of 0. In this case, it's 1 minus 1, which is 0. So we'll have the point 0, 0. We're going to keep doing that same thing. So right now, I want you to pause your video, and I want you to go ahead and calculate the rest of these values. All right, hopefully you got the same values I listed on the board. Now we're going to go ahead and start plotting these. So let's plot 0, 0. Pi over 6, and we're going to go 0.13, so just a little tiny bit there for pi over 6. Pi over 3 gets a half. Pi over 2 gets 1. 2 pi over 3 gets 1.5. 5 pi over 6 gets 1.87, and pi goes all the way out here to 2. Now, remember, we said this graph is going to be symmetric over the polar axes, or over the x-axis. So now, using that symmetry, I can take all these points and flip them down and get some equivalent values here. And now we can go ahead and connect the dots, and you can see we get this swirly shape. That's where we're going to end for today.